Section 2.2, Functions and Graphs. Identifying functions. A function is a correspondence between a first set, called the domain, and a second set, called the range, such that each member of the domain corresponds to exactly one member of the range. An example of a function would be the domain, a grocery item, the range, the price. So if you purchase 5 loaves of bread that are all the same, you expect each one to ring up for the same price. Your input is the grocery item, your output is the price. If you bought 5 loaves of bread and the first loaf cost $1.49, the second loaf cost $2.50, you would say, wait a minute, why is the price different? The price should always be the same. Every grocery item should have one and only one price when they ring it up. Another example would be a letter on the phone dial, and the range would be the number on the phone dial. So if somebody tells you that their phone number is call me 2, then you would look at your phone dial and you would say, okay, C, the number 2, A, the number 2, L, the number 5, L, the number 5. So you would dial 2255, then me, 632. That would be the final number. So every letter on the phone dial corresponds to one and only one number on the phone dial. It is a function. What about this example? Is this a function? The domain, the numbers 5, 2, and 8. If you put in the number 5, you get out the number 2. If you put in the number 2, you get out the number 4. If you put in the number 8, you get out the number 9. This is a function. Is this a function? When you put in the number 1, you get out a 0 sometimes, but sometimes you get out a -1. You put in the number 1 and you get out 2 different numbers. It is not a function. Is this a function? You put in the city of New York, sometimes you get out the Giants, sometimes you get out the Jets. You put in the city of Dallas, you get out the Cowboys. Is every member of the domain corresponding to one and only one element of the range? No. This is not a function. Is this a function? This time we start with the team. You put in the Giants, you get out New York. You put in the Jets, you get out New York. You put in the Cowboys, you get out Dallas. Is this a function? Yes. It doesn't matter that 2 teams have the same output. The requirement for a function is that every member of the domain has one and only one associated member in the range. Are these functions? The domain is the members of the class. The range will be a set of numbers corresponding to each member's social security number. So does every member of the class have one and only one social security number? Yes, it is a function. Does every member of the class have one and only one credit card number? Probably not. Some people have 2, 3, 4 credit cards. So I don't think that is a function. When an algebraic expression describes the correspondence, the notation f of x equals algebraic expression is used. It is read, f is a function that pairs with each value of x in the domain, the value obtained when that x is substituted in the expression, or more simply, thank goodness, more simply, f of x. So when you see f parentheses x, it does not mean f times x. It is read f of x. It's a function notation. It is just another way of saying y, the letter y. So in this particular example, y equals 3x minus 1 can be written as f of x equals 3x minus 1. it's just, f of x is just another way of saying y. And it doesn't actually have to be f of x. It could be g of x, h of x. You can use pretty much anything for f. It's just a way of saying something is about to happen to x. Something is about to happen to what is in the parentheses. When x is 0, what is y? Another way of saying that is f of 0. What happens to 0 in this function? What is f of 0? Well, we've got to find out. You can think of f of x as a fill in the blank. F of whatever's in the blank is 3 times whatever's in the blank minus 1. So that's what we're going to do. What is f of 0? It's 3 times 0 minus 1. 3 times 0 is 0, minus 1 is minus 1. When x equals 5, what is y? Another way to state that using function notation is f of 5. What is f of 5? Well, let's find out. F of 5 is 3 times 5 minus 1. That's 15 minus 1, 14. F of 5 is 14. Given that f of x equals 4x minus 5 and g of x equals 3x squared minus x, let's find these values. So what is f of 2? We have to use our definition for f of x. What happens to x? 4 times whatever's in the parentheses minus 5. 4 times 2 minus 5. X is 2. 8 minus 5, 3. What about f of negative 3? So we have 4 times negative 3 minus 5. That gives us negative 12 minus 5, negative 17. F of negative 3 is negative 17. What about g of 2? Now instead of using f of x, we want to use g of x. This function defines what we're going to do. G of 2, whatever is in the parentheses, we have 3 times whatever's in the parentheses squared minus whatever's in the parentheses. Using our order of operations, that's 3 times 4 minus 2, 12 minus 2, 10. G of x minus 1. Be very careful with this one. We're taking out the x and we're replacing it with the quantity x minus 1. So we have 3 times x minus 1, quantity squared, minus x minus 1. Let's zoom in on here so we'll have some more room. So what does this give us? Well, we have to square x minus 1. That means we need to write it down twice and multiply. We have to use the distributive property so that it's minus x plus 1. Let's go ahead and multiply these two guys together. That will give us x squared minus 1x minus 1x is minus 2x plus 1 minus x plus 1. 3x squared, let's multiply through by 3, minus 6x plus 3 minus x plus 1. 3x squared. We're going to combine our like terms. Minus 6x minus x is minus 7x. And plus 3 plus 1 gives us plus 4. 3x squared minus 7x plus 4. Vertical line test. A graph represents a function if it is impossible to draw a vertical line that intersects the graph more than once. Determine whether each of the following is the graph of a function. It is a function if any vertical line you draw intersects the graph either not at all or one time. This is a function. It is not a function if there is anywhere that you can draw a vertical line that intersects the graph more than one time. This is not a function. Is this third example a function? Yes. Every vertical line we can possibly draw intersects the graph at most one time. It is a function. Graphs of functions. Here we have a graph of the cable company's revenue based on their monthly charge. So the monthly charge ranges from $0 to $90, and the revenue ranges from 0 to, the graph goes, the y-axis goes up to $120,000. So does this graph represent a function? Yes, it does represent a function. It passes the vertical line test. Every possible vertical line that you could draw through this graph cuts the graph at most one time. What is the revenue if the monthly charge is $20? Well, let's get a monthly charge of $20. Go up to the graph. Go over to the revenue. It's halfway between $60,000 and $80,000. Looks to me like $70,000. What monthly charge will maximize revenue? Where is revenue maximized? The revenue achieves its largest value right here. What monthly charge maximizes revenue? $45. If you charge less than that, you're not making enough money. If you charge more than that, people will cut off their service and they won't purchase it. So you're in trouble. So $45 is where you achieve your maximum revenue. What is R of 30? Find 30, go over. I believe it's $90,000. What is R of 60? Find 60. Go up to the graph, find the point, go over. It is also $90,000. And that's all of this section. If you need to go on to the next section, check the next video.